Alright, so good day everyone. So in this part of my class, I'm going to be explaining systems. What are systems? Systems are part of the universe that is under study, and that is what we call a system. While surrounding is part of the universe that is not under study. And what separates the system from the surrounding is called a boundary. Or what separates two or more systems is called boundary. Take for example, let's say I have a cup of coffee, and this is a cup of coffee, and let's say it is closed. This coffee in this cup is termed the system, and there are other gases in the environment. But because we are not interested in the gases or any other substance in the environment, we term this the surrounding. And what separates this cup of coffee, which is our system, from this surrounding is called boundary. So a boundary is a real or imaginary line which separates the system from the surrounding. But in this class, we are really interested in systems. Now, what do we call systems? As I've said earlier, I said a system is part of the universe that is under study. Now, under thermodynamics, there are types of systems. And the first type of system that we are going to be discussing in this class is called an open system. An open system. Now, what do we call an open system? An open system is one of the types of system which allows the exchange of heat and matter between itself and the surrounding, or between itself and another system. Take for example, let's say I have a cup of coffee, but now the cup of coffee is widely opened. So if you look at the coffee, let's assume the coffee is very hot. So it simply means when you check the opening of the cup of coffee, there will be some steam coming out. There will be some steam coming out of the cup of coffee. All these steams coming out, they are the matter and they are being exchanged with the surrounding. And when you check the boundary of the cup, you notice that the boundary is quite hot, showing that there is exchange of heat between the system and the surrounding through the boundary. So this type of system is termed an open system. So an open system allows both the exchange of matter and heat between itself and the surrounding, or between itself and another system. And that is why the change in matter in an open system must not be equals to zero. And also the change in heat of an open system must not be equals to zero. So this is what we termed an open system under thermodynamics. The second system that we are going to be discussing is called a closed system. A closed system. A closed system is a type of system that allows only the exchange of heat through the boundary. So if I have a cup of hot coffee, but the cup of the coffee is closed, so it simply means matter cannot move out of this system. So when those heats are trying to move out, when those matter are trying to move out through the opening of the closed system, they tend to hit the lid, and when they hit the lid, they lose their kinetic energy to the lid and turns back to the liquid and fall back into the liquid. But when you check the side or the boundary of the system, you will notice that the boundary of the system is also hot, showing that there is still exchange of heat through the what? Through the boundary, but no exchange of matter. So a system that allows only the exchange of heat through the boundary is called a closed system. And that is why in a closed system, the change in matter is always equals to zero. Why? Because there is no exchange of matter between the system and the surrounding, and then the change in heat must not be equals to zero because there is continuous exchange of heat between the system and the surrounding. The third type of system that we are going to be discussing is called an isolated system. An isolated system. An isolated system is a system that doesn't allow both the exchange of matter and heat between itself and the surrounding. And that's what we call an isolated system. So before a system could perform that kind of function, it simply means the system is either lagged or it is insulated. A typical example of an isolated system is a food flask or the calorimeter that we use in the laboratory. So if I have a system and the system is lagged, the system is lagged, the system is lagged. The function of this lagging or this insulating material is to protect the system from exchanging heat with the surrounding. So if I have my coffee, but now the system is closed, no exchange of matter, the system is lagged, no exchange of heat. It simply means the system can neither exchange heat nor matter with the surrounding, and that system is what we call an isolated system. And that is why in an isolated system, the change in matter is equal to zero and the change in heat is equal to zero. So these are the three types of systems that we are going to be discussing in this phase of this class. In my next lecture, I'm going to be explaining other types of systems like isobaric, like isochoric, like isothermal, like adiabatic, and so on and so forth. So I meet you guys in my next class. Thank you very much.